Hello everyone, welcome to my channel Engineering Network. Today we will learn about lay plane, that where we should provide how much lay plane. In this video we will briefly discuss the lay plane for column, beam and slab. So to start this very important video, first subscribe to my channel and also click on this small bell icon so that you will get notified on time when I publish a new video. So let's get started. Okay, so let's first talk about what is lay plinth. It is one of the most important terms used in reinforcement, and it can be defined as lay plinth is provided to maintain the continuity of bars in order to safely transfer the loads or stresses from one bar to another bar. Now the question arises is, why do we provide lay plinth? In multi-story buildings, we provide number of continuous beams and columns, and as we all know that the standard length of a steel bar is 12 meter. So during the construction, when steel is to be provided for a length greater than 12 meter, the bars are laid to maintain the continuity of reinforced structures so that the loads that are coming from the top of the building can safely transfer from bar to the foundation, and the portion where two steel bars are joined is called lay plinth. This lay plinth varies for different RCC structures and lies between 30D to 60D depending on the design and grade of concrete. Now let's talk about what are our lay plinth for column, beam and slab. So let's first start with column. Now one thing you should remember that the lay plinth depends on grade of steel and grade of concrete. So based on structure and type of loads, a structure engineer tells us how much lay plinth should be provided. So as per the codes, the overlay plinth for column should not be less than 75 mm. In case of column, we take the lay plinth of 24D to 45D, where D is the diameter of bar. So as I told you that the lay plinth depends on grade of steel and grade of concrete. So depending on the type of steels used in your structure and concrete, you have to choose the lay plinth, but mostly we take 45D lay plinth for column. Now there is some important points that you must remember for column lay plinth. The first one is lapping should be provided at the center of column, because the bending moment at the center of column is 0, so try to lap at the center. Now the question arises that where we will provide the lay plinth at the center. So let me explain you that. For example, if the length of the column is L, then we have to divide the length of the column in 4 equal parts. So excluding the L by 4 from top and bottom, the remaining length or area is called lapping zone, and in that lapping zone you can provide lapping. For example, the length of the column is 4 meter, and I have divided it in 4 equal parts which will be 1 meter each. So excluding 1 meter from top and bottom, the remaining length or area in the middle is called lapping zone, which is 2 meter, and in that 2 meter you can provide lapping. Another important point that you should remember that the bending moment at the top and bottom of the column is maximum. So we cannot provide lapping at the top and bottom, and that's why lapping is provided at the center of column. Next is lapping of bars should be provided alternatively. Basically it means that in columns vertical bars, the lapping are not provided at the same point. If you provide lapping in same sequence, then there is a chances that buckling may occur in the column at that point. Lateral ties should be provided closely spaced in lapping zone, which means that in the lapping zone the spacing of ties or stirrups should be less than the spacing at the non-lapping zone of that particular column. For example, as per design, if the spacing of ties in column is 250 mm, then the spacing of ties in lapping zone for that particular column should be at least 150 mm. Now we will talk about lapping in beam. Okay, as you know that beams have two zones. One is the upper zone which is called compression zone, and the second one is lower zone which is called tensile zone. So as per the codes for lay plinth of beam, we take 24D for compression zone and 50D for tensile zone. The best zone of lapping is where the beams are 0 for continuous beam or in the bending moment diagram where the values cross at the x-axis or at 1/4 for simply supported beam. In simple words, the lap length of beam in compression zone is 24D and in tension zone is 50D. Lapping should be done in the middle third of the beam. So basically, unlike the columns, the lapping should not be provided in the center of beam because bending moment is maximum at the center of beam. So if it is not okay to provide the lapping at the center of beam, then where should we provide lapping in the beam? The answer to this question is the lapping should be provided where the beam and column connects with each other, which in simple words called column beam junction. So if there is a situation that you cannot give lapping in column beam junction, then what should you do? So then the lapping should be provided at distance of L/4 from the column beam junction. Rings should be closely spaced in lapping zone, same as in column. The spacing of rings in beams should be less than the spacing of rings in the other part of the beam. Lapping of bars should be alternate, same as in the beam. At last, let's talk about slab. As per the codes, for lap length of slab, we take 60D where D is the diameter of bar. So perfect lapping must be a zone of zero bending moment or where the tension is low. The lapping should be provided at the point of contraflexure. The contraflexure is that point in a bending moment diagram where bending moment is zero. So this is some basic concept of lapping in beam, column and slab, that where you will provide the lapping and how much it should be. So I hope that this video will clear lots of your questions about lap length. If you like this video, then please click on the like button, share it with your friends, and if you haven't subscribed to my channel yet, then please click on the subscribe button and also don't forget to click on this small bell icon so that you will get notified on time when I publish a new video. See you in the next video.